Newton's Laws of Motion by Austin Ayotte. Sir Isaac Newton. Isaac Newton was a mathematician and a physicist. He produced the Laws of Motion in 1687, and he is extremely influential to the development of the knowledge of physics. Newton's Laws. Newton's first law of motion, the law of inertia. An object in motion remains in motion unless acted upon by an external force. An object at rest remains at rest unless acted upon by an external force. Newton's second law of motion, F equals ma. Newton's third law of motion, every force has an opposite and equal reaction. Newton's first law. The first law, the law of inertia, states that an object in motion remains in motion unless acted upon by an external force. If a body is moving at a constant speed in a straight line, it will remain that way. For example, when you throw a baseball, the reason it slows down and stops is due to air resistance, gravity, and friction once it touches the ground. These are the outside forces acting upon the baseball. Newton's first law example problem. Which of the following isn't an example of Newton's first law of motion? A person braking in their car. B, a person rolling on the ground and slows down over time. C, a book remains on the ground forever. Or D, the table pushes on the apple and the apple pushes back on the table. I'll give you a minute to think. Newton's first law example problem answer. The answer is D. This is because the question is asking which is not the example of the first law of motion. D is an example of Newton's third law, therefore it is the only example not showing how an object remains in motion unless acted upon and remains in rest unless acted upon. Newton's second law, F equals ma. Force equals mass times acceleration. Therefore, in an equation, if the force is constant, if you decrease the mass, the acceleration increases, and vice versa. If a ball is falling in the air, it can be measured by F equals ma or F equals mg, mass times gravity. Newton's second law equations. F equals ma can derive other equations. A equals F over m, and m equals F over a. Newton's second law example. What force must act on a 50 kilogram mass to give an acceleration of 0.3 meters per second squared? I'll give you a minute to think. Newton's second law example answer. The answer is A. This is because of the equation F equals ma. They are asking for the force and provide the mass and the acceleration. Therefore, you just multiply and find your answer. F equals 50 kilograms times 0.3 meters per second squared. F equals 15 newtons. Newton's third law. Every force has an equal and opposite reaction. For example, a ball sitting on Earth is applying a force through the ground, and the Earth is applying the equal force back up. The picture shows this demonstration. Or doesn't show this demonstration, but shows a similar demonstration. On an airplane, the engine is pushing forward, and the exhaust flow is pushing backwards, causing the airplane to move forwards. Newton's third law example. Which is not an example of Newton's third law? A basketball player jumping for a dunk. B, a track athlete sprinting 100 meters. C, a plane flying through the air. Or D, a baseball player lowering his hand while catching a ball. I'll give you a minute to think. Newton's third law example answer. The answer is D. This is because this particular example is showing the change in momentum of the ball, not a force acting and an equal force acting in the opposite direction. Finally, Newton's influence on physics. Newton's laws of motion have a huge influence on physics. In his book, commonly known as the Principia, he published these laws. He laid the foundation for the future knowledge of physics. Newton was a very smart man and was said to create a theory of gravity and calculus, which also have a huge impact on modern physics knowledge. He helped understand the conceptual knowledge of motion and how they work. Overall, his influence in the physics world was immense. And list of my sources.